So there are basic volume problems that you might see in a test, which would look like either here's the length, width, and height, what's the volume, or here's the volume, and two of the dimensions, solve for the missing one. Those are basic types of volume problems. There are also volume problems that are a lot more challenging and have a lot more steps. Those are the kinds of problems I'm going to be modeling here in this video so that you'll be able to know how to tackle them when you see them on a test. Okay, we're going to look at 3 example problems. The first one says, the volume of a rectangular prism is 320 cubic feet. It is filled 75% with dry sand that weighs 110 pounds per cubic foot. What is the weight of the sand? So let's break it down first of all. We have a rectangular prism. Let me draw one here. Oops. So it is a rectangle. It's 3-dimensional. And the total volume is 320 cubic feet. But it's only 75% filled. So we have to figure out first, what is 75% of that total volume? Now, one option is to change 75% to a decimal and multiply. The other option is to change 75% to a fraction and multiply. Actually, technically there are 3 options. You could also set up a part-whole percent proportion and solve that way. Let me quickly model all 3, and in the future I'll just use one of them. Alright, so if we wanted a part whole equals percent out of 100 proportion, we know that our percent is 75. We know that the whole volume is 320, and we're looking for the part that represents the 75% done. Alright, so looking from here to here, do I see a scale factor? Not one that I easily recognize. How about from 100 to 75? Still not one that I easily recognize. Okay, so if that's the case, then I'm going to simplify my completed fraction. I know that 75/100s, I can divide both 75 and 100 by a factor of 25, and that gives me 3/4. Can I get from 4 to 320? Well, I recognize pretty quickly the relationship between 4 and 32. That's times 8. But with a 0 on the end would get me times 80 equals 320. So I'm going to take that 3 and multiply it times 80. 3 times 80 is going to be 240. My units are feet cubed. That's a pretty straightforward way to do it. It's pretty similar to the way you would do it in fraction form, which is to say 75% simplifies to 3/4. 3/4 of 320. Of means multiply. You would say 3/4 times 320 over 1. And that would give you, when it's simplified down, a final answer of 240 as well. The decimal option would be to say, well, 75/100s. 75% of this whole volume. Of still means multiply. 320. However you chose to do it, you would still get the same answer of 240 cubic feet. Alright, I'm going to erase this work to give myself some more space because these kinds of problems are multi-step. It takes a lot of room. This would be a kind of problem that I would break out the scratch paper on because the star will give you that one sheet of grid paper as scratch paper. This is what I'd be using it for. Okay, so we know that 75% filled means that we're talking about 240 cubic feet worth of dry sand. Yay. Don't know what you're doing with all that dry sand, but it's there. And it weighs 110, let me switch colors, 110 pounds per cubic foot. So per means for every one. For every one of these 240 cubic feet, it's 110 pounds. So I have 2 choices. I could say, well, 1 pound is 100, or 1 cubic foot is 110, plus another one, but I'd have to do that 240 times, so that's not looking too fun. The faster way to do it is to say 110 times 240. Now, it can be kind of overwhelming to do multi-digit multiplication, so here's my method. I'm starting with this right here. 0 times 0 is 0, times 4 is 0, times 2 is 0. Moving on. New color, new section. I'm going to do all this, and I'm going to start writing my answer underneath my blue 1. 1 times 0 is 0. 1 times 4 is 4. 1 times 2 is 2. New color. 1 times 0, starting underneath this red one, is 0. 1 times 4 is 4. 1 times 2 is 2. Add it all together. 0 plus nothing is 0. 0 plus 0 is 0. 0 plus 4 plus 0 is 4. 2 plus 4 is 6. 2 plus nothing is 2. No decimals. My answer would be F. Next problem. 1 cubic foot. A cubic foot means one of them. Of water weighs approximately 62.5 pounds. Dang, that's pretty heavy. Didn't know it, but water's real heavy. A rectangular prism is 6 feet long, 4.5 feet wide, and 8 feet deep. What I would do, pause right there, I would go ahead and calculate the volume of that prism because it's most likely going to show up, and I'll probably need to do it anyway. Plus, it's a nice little brain break for me from reading this long thing. 6 feet, 4.5 feet, definitely not to scale because 4.5 is smaller than 6, but it's okay because I know I'm going to multiply them all together. All right, 6 times 4.5 is going to be 27 times 8. 8 times 7 is 56. Whoa, 56. 8 times 2 is 8 and 8 is 16, plus 5 is 21. So we have 216 cubic feet, or feet cubed. All right, it is only 50% full. Oh, okay. Not all the way full. This is the whole volume of the entire thing, but I only filled it 50%. That means half of it. So half of 216 divided by 2 is going to be the volume at 50%. Is 108 feet cubed. What is the weight of the water? This is in feet cubed. That is not weight. That is volume. So I have to go back up here to where it says that 1 single cubic foot is 62.5 pounds. And then I'm going to multiply 62.5 times 108, because every one of those 108 cubic feet is 62.5 pounds. Notice, 108 is a whole number, there are no decimals. 62.5 has a decimal. I do not need to add a 0.0 to the 108. When I'm multiplying, I don't need to stack my decimals. All right, gonna do this real quick. All right, I just did my multiplication real quick. You can see I used my color sorting strategy to help me. And I get 67,500. Oh, but wait. There is one decimal point in my problem. That means that I'm going to have one number behind my decimal point there. Here's my oopsie. I included this griddable right here, which has the ones, tens, hundreds, and thousands place. It does not have a, oops. Oh, I was wrong. This is the wrong problem. Never mind. Ignore me. This will fit. 6,750 and 0 tenths. You don't actually need the 0, but that's okay. You can add it. You do definitely need to bubble in addition to writing in, because if you just write it, no one will grade it. Look, this would actually get marked as an error because check it out. I have this green thing that looks like it's kind of highlighting the 4, so when the computer reads it, it would mark this as we don't know what that is because it's a 4 and a 6 that have been highlighted. So you need to be super careful that you have only made marks inside the bubble of the number that you actually want. If it's a positive number, you don't have to have your plus sign, but if it's a negative number, you absolutely do. Last one. A rectangular aquarium is 8 feet by 3 feet by 6 feet. Okay, I'm gonna pause right there. I like to chunk my work. I'm gonna figure out what the volume is. Now, in this, I've been doing a pretty terrible job of modeling me writing my area formula, or my volume formulas. My bad. Let's go ahead and assign some numbers. 8, 3, 6. I'm going to find the area of my base. That is 6 times 3 is 18. 18 times 8. Well, 8 times 8 is 64. 8 times 1 is 8, plus 6 is 14. My volume is 144. What were my units? Feet cubed. Okay, don't fall for it. It's not my final answer. All right, a cubic foot of water is approximately 7.5 gallons. Okay. How many gallons of water will the aquarium hold if it's 75% full? I could solve it two ways. I could multiply this volume, the 144, times 7.5, find how many gallons would fill the entire thing, and then find 75% of that. Or I could find 75% of my volume and then multiply it. I'm going to do the 75% first, because that should give me a slightly smaller number than 144, and hopefully that'll be a smaller number to multiply 7.5 by. Okay, so 75% is out of 100. 144 is my whole volume. I don't know the part that is 75% full. I don't know how to get from here to here. I can't easily scale that way, so I'm going to simplify. 7,500 simplifies to 3/4. Can I get from 4 to 144? Why, yes, I can. It would be times, I know I can, but what do I do if I don't know right away what my scale factor is? Here's what I do. I take 144 and I divide it by 4. 4 goes into 1 0 times. 4 goes into 14, 4, 8, 12, 16, nope, 3 times with a remainder of 2. 4 goes into 24 6 times with no remainder. All right, my scale factor is times 36 because that was my quotient when I divided 144 divided by 4. And these three numbers make up a fact family. So it has to be times 36. 3 times 36 is going to give me, 3 times 6 is 18. 3 times 3 is 9, plus 1 is 10. 108. Again, don't fall for it. At least the 144 wasn't listed as an answer choice. 108 is. But this is the volume of this aquarium when it's 75% full. Volume is measured in feet to the power of 3. This is in gallons. C is trying to trick you into being like, I found my answer. Nope. You found the volume of the aquarium when it's 75% full. I'm going to clear myself some space. Okay. So, these are really long problems, and it's super helpful to pause after every step and figure out what your units are, because a lot of the time your units will tell you, are you done? Is this your answer? Or like here, I was like, oh, my volume at 75% is 108 feet cubed. Then you go over and look at your answer choices and realize those are not in feet cubed. So something clearly either went wrong or still needs to happen. It still needs to happen. 108 times 7.5, because every single one of those, what are they called? Cubic feet is 7.5 gallons of water. All right, just did my multiplication with my colorful strategy, and I'm noticing that I have a decimal point and one number after my decimal point, so I'm going to need to put it right here where it has one number after the decimal point. So my final answer is that the aquarium, when it is 75% full, holds 810 gallons of water. That would be D. And those are some examples of how to solve the more complicated volume problems, especially when they include a percentage full amount. Hope this was helpful.